Aesthetic, inlay, and onlay. The need for amalgam alternatives and the growing demand for the more aesthetic restoration had led to introduction of new materials and techniques to be used for large posterior restoration. An inlay is indirect restoration constructed of gold or cast metal, porcelain, or composite that never supports nor replaces a cusp or cusps of the tooth. The inlay restoration is nothing more than a centric stop in that it provides no protection for the cusp tip as concerned lateral and or protrusive masticatory forces. An onlay is indirect restoration that covers one or more cusps extending through and beyond the cusp tip to facial, lingual, and proximal slopes of the covered cusps. The occlusion in all function positions is supported by restorative material rather than tooth structure. Aesthetic, inlay, and onlay. Indications for inlay and onlay overlay of posterior teeth. Number one, extensively damaged teeth where the direct restoration cannot solve the problems of restoring proper contour, contact, and occlusion. Number two, uncooperative patient. Wise management of such a patient requires minimizing chairside time by taking an accurate impression and completing most of restorative steps outside the patient mouth. Number three, deeply seated subgingival cavities, where the proper finishing and polishing of direct restorations is difficult, if not impossible. Number four, good standards of oral hygiene. Number five, cavities free from marked undercuts. Number six, sufficient tooth structure available for bonding. Number seven, occlusal load must not exceed the flexural strength of restoration tooth complex. Number eight, the tooth must not show evidence of excessive wear. Number nine, ideally the cavity margin must be placed in enamel. Contraindications of indirect aesthetic restoration of posterior teeth. Number one, poor oral hygiene. Number two, excessive tooth wear. Number three, impossible moisture isolation. Number four, insufficient tooth structure available for bonding. Advantages. Number one, more biocompatible due to less residual monomer, less heat transmission to the pulp, less eye hazards. Number two, improved physical properties. Number three, less microleakage. Have certain advantages over direct composite restoration. Number one, improved physical properties. Number two, variety of materials and technique. Number three, wear resistant. Number four, reduce polymerization shrinkage. Number five, ability to strengthen remaining tooth structure. Number six, more precise control of contour and contacts. Number seven, biocompatibility and good tissue response. Number eight, solving of occlusal problems such as attrition with decreased vertical dimension and collapse lower third of the face may cause temporomandibular joint troubles. Number nine, correction of aesthetic defects such as excessive discoloration caused by fluorosis and tetracycline stains where it is difficult to be removed by other aesthetic alternatives. Number 10, lack of accessibility. Number 12, the ability to restore the contact, contour, and occlusal apart from the restricted inaccessibility of the oral cavity. Number 12, less chair side time. Disadvantages. Number 1, increased cost and time. Number 2, technique sensitivity. Number 3, liberalness of ceramics. Number 4, wear of opposing dentition and striations. Number 5. Resin to resin bonding difficulties. Number 6. More tooth reduction to create path of insertion. Composite inlay and onlay. The third generation of the materials suffer from low flexural strength 10 to 6 megapascal, low modulus of elasticity 2000 to 5000 megapascal, and low resistance to wear abrasion. These poor mechanical properties were the result of low filler load and high matrix load. Second generation improvement occurs mainly in the three areas: number 1, structure; number 2, composition; and number 3, polymerization technique and fiber reinforcement. Structure and composition. Microhybrid filler with a diameter of 0.04 to 1 micron. The filler contents was as twice that of the organic matrix. Flexural strength 120 to 160 megapascal. Elastic modulus from 8.5 to 12 gigapascal, and reducing wear. Techniques. Even additional light curing, etc. orally did not efficiently improve the degree of conversion. Thus, a specific condition like heat, vacuum, pressure, and oxygen-free environment are utilized for polymerization of second-generation indirect composite restoration. The various techniques used for additional curing are: number 1, heat polymerization. The temperature applied in this treatment must be above the composite glass transition temperature. This allows a significant increase in polymer chain mobility, in addition to an increase in cross-linking and stress relief. We have to avoid overheating, which may cause dehydration of composite. The heat can be applied in autoclave, cast furnace, or special ovens. Post-curing heating of resin composite material decreases the levels of unreacted monomer after initial light cure stages. Basically, two mechanisms can involve in this phenomenon. First, the residual monomer will be bonded to the polymer network as the result of heat treatment, leading to an increase in conversion itself. Second, unreacted monomer will be volatilized during the heating process. The combination of heat and light increases the thermal energy sufficiently to allow better double bond conversion. It was observed that the wear resistance increased by 35% on curing with both light and heat when compared to curing with light only. Number 2, nitrogen atmosphere. Air, because it contains oxygen, tend to inhibit polymerization and also play an important role in the apparent translucency or opacity of the cured resin restoration. Oxygen embedded in the restoration tend to break up or diffract natural light as it reflects from the surface of restoration. Removing all of the embedded air causes the restoration to become considerably more translucent. Interrupted oxygen increases the wear rate by weakening the wall around it. Nitrogen gas eliminates internal oxygen before the material becomes to cure. This influences the degree of conversion, aesthetic, wear, and abrasion. Soft start or slow curing. This method tends to be a reliable way for combining improved physical properties with increased marginal integrity. The concept of slow curing is based upon the concept that slow rate of curing tend to allow greater level of polymerization, while faster rate of polymerization tend to be prematurely increase the rigidity of newly formed polymerized branches. The combination of the programmed level of the low light intensity followed by high intensity produces oscillation that is more wearisome than the base composite resin that are light cured only. For fiber reinforcement, glass and polyethylene are the commonly used fiber in dentistry. Fibers act as crack stoppers and enhance the property of composites. The resin matrix acts to protect the fiber and fix their geometrical orientation. Technique of posterior composite inlay and onlay. Restoration system. Number one, combine direct, indirect, or what we call it semi-direct technique or in-office. Include A. Semi-direct intraoral technique, B. Semi-direct extraoral technique, or what we call it flexible module technique. Number two, the indirect technique on stone die or digital impression CAD/CAM system, either in office or in laboratory. Semi-direct method. A. Intraoral technique, semi-direct composite inlay. This technique is indicated for the restoration of one or a maximum of two teeth at any one time. The inlay is formed by placing a few composite increments into tapered cavity previously insulated with a two-coat of the insulating glycerin gel media. A base of conventional glass ionomer cement is placed to eliminate the undercut. It is recommended that using any resin-based material such as resin-modified glass ionomer cement or compomer or composite be avoided because despite appropriate cavity insulation, the composite inlay may adhere to the base, impeding the removal of the inlay. After in-mouth polymerization, the inlay is removed and the proximal anatomy, if necessary, is corrected and refined. Lastly, the restoration is then subjected to extraoral light or heat, tempering in oven. The restoration can be luted with a composite resin cement. Disadvantages of this procedure is the difficulty encountered in removing the inlay from the cavity following light curing. This necessitates the careful case selection. Intracoronal cavities of one or two surfaces with a regular, simple design are best indicated for these purposes. Cavities with three surfaces or with several walls are not ideal because the composite resin tend to lock against the wall during polymerization, thereby hindering removal. Caspal covers should be avoided with this technique because of lack of the antagonist references. Furthermore, cavity walls must be free of undercuts, smooth and characterized by a divergence of more than 18 require a sacrifice of sound occlusal to tissue. The principal advantage of this technique is the chairside protection of fluted restoration without the need to take an impression. Semi-direct intraoral technique. Number one, lubrication of inlay preparation. The tooth and cavity preparation are painted with a lubricant on the disposable brush. This lubricant must be compatible with the composite resin inlay restoration material and will allow inlay removal after intraoral light curing. Number two, matrix and wedge placement. A retainer less contoured clear matrix is placed and clear reflecting wedges are placed at the anteproximal gingival margin. Number two, the wedges are firmly placed to create rapid separation of the teeth, compensating for the thickness of the malar matrix band and allowing for the interproximal contact between the inlay and adjacent teeth. Number 3. Composite resin inlay material placement. A high viscosity resin base is placed into a proximal box and gently condensed with a bulb burnisher. The occlusal portion of the preparation is completely filled and gently condensed with a bulb burnisher. The burnisher is preferable to lightly coated with the resin adhesive to prevent adhesion of composite resin to the burnisher. The interproximal area is cured for 60 seconds. Then the occlusal surface is cured for 60 seconds also. 4. Inlay removal. After the completion of the latte curing, the inlay must be removed from the preparation. Number 5. Oven tempering. Separated lubricant is painted on all the inlay surfaces. This will act to exclude air and will allow the inlay to completely cure without an air-inhibited layer. The air-inhibited layer is the softest layer of the composite resin and should be excluded whenever possible. The inlay is then light cured for additional 60 seconds. The composite resin inlay must now be tempered in a special tempering oven. B. Semi-direct extraoral technique. The flexible mold technique. Advantages of a flexible model technique. Number 1. More convenience and fewer traumas for the patient than indirect technique. Number 2. The dentist and in-house laboratory technician or a capable assistant can make the restoration. Number 3. A professional restoration is not needed. Number 4. Reducing time and cost. Number 5. Eliminating contamination of the tooth, a preparation by professional cement debris. Number 6. Less polymerization shrinkage occurs. Number 7. The technique requires minimum clinical time. It is possible to see the restoration within 8 minutes after the impression. B. Extraoral technique, indirect chairside inlay. Disadvantages. Number 1. The cost of impression materials, the time needed for the impression material to set, and possible deformation of original impression when making the flexible die. Number 2. Tooth preparation should not have a thin, weak cusp because the accuracy of the die is compromised as a result of flexibility of the die silicone. Number 3. The opposing reference is not available because the restoration is generated on single base from a single quadrant impression. Number 2. Indirect technique on die. The steps for fabrication include number 1. Impression making. Number 2. Professionalization. Number 3. Cast preparation. Number 4. Inlay fabrication. B. Indirect technique by GATCAM system. Indirect method. Lab processed composite inlays. In the case of class 2 cavities involving partial or full coverage cannot be properly restored using the semi-direct technique. The inlay is fabricated in a die after the separating media is applied to the die. Composite material is condensed in increment into the cavity and light cured for 40 seconds for each surface. The inlay is then removed and heat cured in oven. The advantage of this technique is that the proximal contours can be achieved properly. Ceramic inlay and onlay. Feldspathic porcelain inlay and onlays. After tooth preparation, an impression is made and a masterworking cast is poured of the die stone. The die is duplicated and poured with a refractory investment capable of withstanding porcelain firing temperatures. The deprecation method must result in the master die and refractory die being of the accurate dimension. Porcelain is added into the preparation area of the refractory die and fired in oven. Multiple increments and firings are necessary to compensate for sintering shrinkage. The ceramic restoration is recovered from the refractory die, cleaned of all investment, and seated on the master die and working cast for final adjustment and finishing. Advantages: low startup costs. The ceramic powders and investments are relatively inexpensive, and the technique is compatible with the most existing ceramic laboratory equipment, such as firing furnaces. Disadvantage: technique sensitivity, both for technician and the dentist. Inlay and onlay fabrication with this technique must be handled gently during drying and bonding to avoid fracture. Feldspathic porcelain are weak, so even after bonding, the incidence of a fracture can be relatively high. Pressed glass ceramic. In 1984, the glass ceramic material Dicor was painted and became a popular ceramic for dental restoration. A major disadvantage of Dicor was its translucency, which necessitated external application of all shading. Dicor restoration were made using a loose wax centrifugal casting process. Newer lucite reinforced glass ceramic system also use the loose wax method, but the material is heated to high temperature and pressed rather than centrifuged into a mold. After the tooth preparation, an impression is made, and a working cast is poured in the die stone. A wax pattern of the restoration is made using conventional technique. After spruing investment and wax pattern burn out, a shade cement ingot and aluminum oxide planger are placed into a special furnace. The shade and opacity of selected ingot are based on the information provided by the clinician, especially the desired shade of the final restoration and the shade of a prepared tooth. At approximately 2020 Fahrenheit, the ceramic ingot becomes plastic and is slowly pressed into the mold by automatic machine. After being separated from the mold, the restoration is seated on the master die and working cast for the final adjustment and finishing to reproduce the tooth shade accurately. A heavily pigmented surface stain is typically applied. The ceramic ingots are relatively translucent and available in different shades, so staining for hot-pressed ceramic inlay and onlay restoration is typically minimal. The advantages of lucite reinforced pressed ceramics are their: number one, similarity to traditional wax-up processes; number two, excellent marginal fit; number three, moderately high strength; number four, surface hardness similar to that of enamel. Although pressed ceramic ingot and alloy are stronger than porcelain inlay made on refractory dies, they are still somewhat fragile during drying and must be bonded rather than conventional cemented. Lithium disilicate is available in both pressed and machinable form, and either can be used to fabricate inlay and onlay. The two forms of emax are slightly different in composition, but lithium disilicate is high-strength glass ceramic that also can be used for full crowns or ultra-thin veneers. In vitro testing of this ceramic material has shown very positive results, and it has become a highly popular alternative for inlay and onlays. However, Because the material is relatively new, long-term clinical studies to demonstrate superior performance are lacking. After the illustration has been designed, the computer direct milling device, a CAD-CAM portion of the system that mills the illustration out of a block of high-quality ceramic or composite in minutes. The illustration is removed from the milling device and is ready for try-in. Any need adjustment, bonding, and polishing. Several types of ceramics are available for chairside CAD-CAM restoration fabrication. These include the feldspathic glass ceramic, like Vita Blocks Mark II, Ceric blocks. The ceramic blocks are available in various shades and opacities, and some are even layered to mimic the relative opacity and translucency in the different areas of the tool. Lucite reinforced glass ceramic are available, like IPS Impress CAD. Also, lithium disilicate also is available in machinable form as IPS Emax CAD blocks. Although newer materials are stronger than the original ceramics, less is known about their long-term clinical performance. Tooth preparation. Preparations for a specific type of indirect tooth-colored inlays and onlays may vary because of differences in fabrication steps for each commercial system and variation in the physical properties of the restorative material. Cavity preparation for aesthetic inlay. Number 1. The final preparation does not need extension further than initial defects. Number 2. Eliminate or blocking of cavity undercuts only. Number 3. The key for successful indirect restoration is forming a reliable bond between the adhesive resin and the indirect restoration. Number 4. About joint cover surface margins. 5. Sharp internal line angle must be avoided. Number 6. The importance of contact clearance 0.5 mm with the inlay and onlay preparation are to allow easy penetration of envisioned material between the cavity margin and the neighboring tooth. Otherwise, it will be impossible to separate the die from the cast stone. For better convenience, easy check of the adaptation at the tooth restoration. For only restorations, non-working and working cusps are covered with at least 1.5 mm and 2 mm of the material respectively. If the cusp to be onlay show in the patient as a smile, more aesthetic blended margin is achieved by further 1 to 2 mm reduction with a 1 mm chamfer. If the cusp must be cupped, they should be reduced 1.5 to 2 mm and should be 90-degree curve surface angle. When cupping cusp, especially centric folding cusp, it may be necessary to prepare a shoulder to move the facial or lingual curve surface margin away from any possible contact with the opposing teeth, either in maximum intercuspation position or during a functional movement. Such a contact directly on the margins can lead to premature deterioration of marginal integrity. The axial wall of the resulting shoulder should be sufficiently deep to allow for adequate thickness of the restorative material and should have the same path of drawing as the main portion of the preparation. Inlay and onlay professional restoration. A professional restoration is necessary when using an indirect system that requires two appointments. The temporary restoration protects the pulp dentine complex in vital teeth, maintain the position of the prepared tooth in the arch, and protects the soft tissue adjacent to the prepared area. The temporary restoration can be made using conventional and acrylic resin or base acrylic composite material. Care should be taken to avoid the bonding of temporary material to the preparation at these phases of the procedure. A lubricant of some sort can be applied to a preparation if desired, especially if a resin-based material was used to block out the undercut and level the wall of the preparation. Temporary restorations for the porcelain fused to metal and cast cold restoration typically are cemented with eugenol-based temporary cement. Eugenol is believed to be interfere with resin polymerization, however, and potential could reduce the adhesion of the permanent composite cement to the tooth structure. Although some studies reported this does not occur if the tooth is pumiced before cementation of the permanent restoration, use of non-eugenol temporary cement is recommended. For example, non-retentive preparations or when the temporary base is expected to last longer than 2 to 3 weeks. Zinc phosphate or polycarboxylate cement can be used to increase retention of temporary restoration. Cementation. The preparation surfaces are etched and treated with the component of an appropriate enamel dentine bonding system. Typically, the final step of bonding system also is applied to internal surfaces of restoration, previously etched and cemented. Self-adhesive resin-based cement have been introduced in recent years, but whether they are appropriate with the tooth-colored inlay and onlay remained unproven. A double-cure composite cement is mixed and inserted into the preparation with the paddle-shaped instrument or syringe. The internal surface of the restoration also are coated with the composite cement, and the inlay is immediately inserted in the prepared tooth using a light pressure. A pull burnisher applied with the slight vibration motion is usually sufficient to seat the restoration. Excess composite cement is removed with a thin bladed composite instruments, brush or explorer. Finishing and polishing procedures. After light curing the cement, the plastic matrix strips and the wedges, if used, are removed, and the seating of the resin cement is verified. All margin areas are checked with a probe. Composite luting cement. When we use composite luting cement, there is a certain disadvantages. Number one, polymerization shrinkage, which may create a marginal gap with a loss of marginal seal. Number two, wear of composite luting cement because the wear resistance is low and this is more prominent when gaps are increased. Number three, dissolution of resin matrix in the oral fluids. Light cure and double cure resin luting cements are available for use with veneers, while the light cure material were preferred. More recently, amino-free activated double cure cements have been released, which exhibit far greater color stability. It generally recommended to bond porcelain to enamel rather than dentine. Because dentine is lower modulus material, more flexible than porcelain, it flexes more than enamel under a given load, thus subjecting the veneered porcelain to higher tensile and shear stresses lead to early failure. Finally, I wish to thank you for your nice listening.